By default, when you're viewing a model in the SOLIDWORKS environment, there is no perspective. Perspective is basically how you would view the model based on the distance away from your eye. If you have a very large object, the portion of the object that's closer to you looks larger, and the portion of the object that's farther away from you looks smaller. This is apparent if you're on a very long straight stretch of road. The road very far away looks tiny as opposed to the road right in front of you. When you're modeling, typically you don't want to have perspective on because it obscures things. The way you rotate the model changes, especially if you're using a 3D mouse, makes things just a little bit more difficult. But when you're viewing the model, you want a more realistic view, you might decide to turn perspective on. If you're using a camera view like we've created, the camera view will automatically give you the object in a perspective view. Based on your camera settings, whether or not you have perspective on, and so on, you'll get a more realistic view of the object. But if you're dealing with standard views and you don't have a camera created or you don't necessarily want one, you can go to your heads up view manager, view settings, and you can turn perspective on. What this will do is this will give you the illusion that the object is actually changing scale as it gets farther away from you. And we do have control over this. If we look at this now from a front view, you'll notice that on the left-hand side, we're actually seeing a little bit more of the design than on the right-hand side. Now, obviously, this part is fairly small, so we're not getting a whole lot of distortion here. But as we look at it from the top, you can see the same thing. We're getting a distorted view based on how far away the viewer's eye position is. Once you have perspective turned on, you can go to View, Modify, and down to Perspective. You can change the observer position based on the number of objects away from you this is. Currently, and by default, the observer position is set to 3 object sizes away. Now, as you alter this number, you'll notice some changes in the model. If we go down to 1, the model appears farther away. Now, what this is actually doing is bringing the object closer to our vantage point. Now, these numbers all relate mathematically in the background. We make this number larger, you'll see that the object is starting to look more and more normal as if we had perspective turned off. To understand this a little bit more, let's take a look at another file I created. Open the Perspective SOLIDWORKS part file and edit Sketch 1. Now, inside Sketch 1, there are a few things that we need to look at. First is the set of lines located from the origin off to the right-hand side in positive x direction. The origin is going to be our observer position. You'll notice that the line is 1 inch away and that all these lines have an equal relation. Now, when we're talking about perspective and observer position, an observer position of 1, in this case for a 1-inch object, would essentially be looking at an object from the origin to this point. So the box that we have below us, we would be looking at this box from the origin, and its front is at 1 inch and its back is at 2 inch. Now, what this gives us is a ratio of 1/2. Essentially, the back of the object is half of what the front of the object is. Now, this is true for whatever the object size is going to be because we're dealing with observer position relative to the size of the object. As we move farther and farther out, for instance, the object is located at 3 inches and the back of it's at 4 inches. We now have a ratio of 3 divided by 4, or 3/4. So this gives us a ratio that's getting closer and closer to 1, and it gives us less distortion of the object. Now, I know this is a little hard to understand, but as you start playing with these numbers, you'll start to notice the changes. I've also set up in this file an equation. Now, inside of here, we're controlling the observer position and also all the widths associated with this particular isometric box. Now, as we look up observer position 1, we have the most distortion. You'll notice that the dimension at the front is 2 inches for the square, and the dimension at the back is 1 inch. If we change the observer position, for instance, to 3, you notice the back is now 1.5 inches wide, while the front is still 2 inches. As we get farther and farther away, for instance, 24 inches, we get closer and closer to a ratio of 1 to 1. And you'll notice that the back is now 1.92 inches, and the front is still 2 inches. So what this is telling me is that the higher the observer position number is, the farther away the object is, the less of a difference it makes front to back. Now, of course, there are specific examples of this where you're talking about great distances. For instance, looking at a road. Now, if you're looking at a road, you're essentially taking a wide section that's fairly close to you, and that same width section is extremely far away, and it almost looks like it's going to a point. You really notice this if you're out somewhere that's extremely flat, there's no elevation changes. Now, this is still perspective, but you're dealing with a little bit different topic because your observer position is not dictated by the object size. If you're looking at something like a bus from the front, you'll notice that you can see the entire front of the bus, but you can't see down the sides of it. If you back up a couple hundred feet, then the distance or the length of the bus doesn't matter as much, and you can start to see some of that extra detail. Now, let's hop back to the original JBL speaker file, go back into View, Modify, and Perspective, and take another look at these positions. So position one gets extremely close to the object. Now, even though lowering this number makes it appear as if it's farther away on the screen, it really is only relating to the distortion of the object. We can still move this object around. It doesn't have an effect on the perspective in terms of where it is on the screen. It's only dealing with this observer position. If we make it something much higher, such as 24, it looks very close to the object if we turn perspective off. Now, if we get even higher, say an observer position of 50, there is almost no difference between the object with perspective on and with it off. Of course, setting it that high would really be silly unless you have a very specific example where you need to do that. In most cases, the observer position of 3 is going to be perfect for turning perspective on and off. If you need any more control, usually creating a camera will give you that extra bit of control.